resources page. Just give me a second while I like configure certain settings, and then we can start. We have Pratyaksh, who's a developer advocate at IBM, who's also an expert at this topic, who's going to be walking you through everything. And we also have Saurabh. So if there's any question from IBM itself, so if you have any questions, any feedback regarding today's session, you feel free to use the Q&A button, which is present at the bottom of your console. And you are currently, because you're currently in a listen only mode, you won't be able to utilize the chat button. So yeah, and as for me, my name is Yukti. One of my main jobs here at Single Store is to bring these webinars to you. So yeah, like if there's any feedback, or if you have any ideas that you're working on, or maybe if you have an interesting use case which you're utilizing Single Store for, and as a matter of fact, even Presto DB, our DMs are always open. So feel free to shoot a message. So yeah, today's I don't think so that I mentioned, but today's webinar is called Optimizing OLTP and OLAP Queries with PrestoDB and SingleStore. So yeah, Pratyaksh, you're able to share your screen.
Yeah, let me quickly try that.
So I have the links for everyone to try. So yeah, I would highly recommend that everyone whatever's your preference, but we recommend that you follow along in real time. And I'll be giving you a link to try out Single Store DB. We actually offer $600 worth of free credits. And because today's webinar is about showcasing Single Stores and Presto's OLAP and OLTP query processing capabilities. So stay tuned. And like we have a good GitHub repository that Saurabh has just sent me. And yeah, one more thing. It's a very interesting fact, but Presto is open source and also free of cost. So highly recommend to follow along in real time so that you can make the most out of your time. And if there's any questions, we can always address them towards the end of the session. We will be hosting a Q&A round that, and our panel is going to take care of that. So yeah, Pratyaksh, please take it away. And thank you so much for your time in putting everything together.
Sure, Yukti. Just give me a minute.
I am dropping the link to try out Single Store for free and avail your $600 worth of free credits right now. And I will be dropping the GitHub repository that Presto is going to use for the demo today in the chat. So feel free to keep an eye out. Just have with you in a second.
Can I start in the meantime?
Yeah, absolutely, absolutely. Please take it away.
Yeah, okay. Okay, thank you, Yukti, and thank you, Saurabh, for giving this opportunity. Hello, everyone. Good morning and good evening. You might be joining across time zones. Not very sure about from where you are joining in. So, in this talk, like we are going to talk about the combination of Presto and Single Store, which is like quite obvious to all of you. So we'll try to see how you can unlock some lightning fast real-time insights from your data, which might be present in like different data sources, right? So we'll basically try to answer three major questions here. The first one is what, then why, and how. Like, what are these insights? Then how are these insights? How can you get these insights? And the third is why do you need these insights, right? So the answer to the second question is like quite obvious. How do you get these insights? I think many of you can guess. The answer is the combination of Presto and Single Store. Using this combination, you can get a lot of great insights from the data, which is like already available in your databases. So Right. Okay. So, yeah. Okay. So, let me try to give some context before we actually start. So, in today's talk, we'll first talk about some of the challenges that the enterprises in today's world they face on a day-to-day basis, which are mostly related to the volume of the data. How do you ingest this data? How do you kind of maintain this data, and how do you query this data for doing any kind of analytics, right? After quickly talking about the challenges, we'll talk about single store. We'll quickly talk about its architecture, what are some of its strengths. Then we'll switch to Presto. We'll talk about some of its strengths as well. We'll have a quick look at the Presto architecture, and finally we'll have some demo and also talk about the major use cases for which this combination of Presto and single store can be useful for you guys, right? And finally, we'll be having some time for Q&A. In the meantime, you guys can feel free to post your questions in the chat, and either one of Yukti and Saurabh can help answer them, or else I'll be answering them at the end. And like, who should be caring about this talk? I think anyone who is like enthusiastic to learn, to know more about Presto, to know more about Single Store, and definitely anyone who is dealing with the data related use cases on a day-to-day basis, right? For example, engineers who are building and optimizing their data pipelines, and like from these engineers to someone who is like more interested in optimizing their data platform solutions, right? Someone like a architect or analyst, all of them, this talk is going to be extremely useful. And to quickly talk about who I am, so I'm Pratyaksh. I have total 9 years of experience. For the last 6 years, I have been working in open source. I started my open source development journey by working on Apache Hudi. I was working on it for like few years. Then, so also I was involved in like building CDC pipelines from scratch in couple of organizations where I was working for. CDC, as many of you might be knowing, CDC stands for Change Data Capture. So I was like involved in building those pipelines from scratch. And most recently, I have been working on Presto for the last 3 or 3.5 years, I guess. So yeah, that was a quick introduction about me, and let's get started. Okay, so let us first talk about some of the challenges which enterprises or companies in today's world face, right? So basically, companies these days they are generating a lot of data in different formats. Like whatever we are doing as end users, we are basically generating data for them. From something as simple as browsing some website to something like doing some shopping or traveling from one place to another, all of these activities are generating data for the companies or for the service providers, right? So all of this data is being stored in different formats and in different locations depending on the nature of this data and what use case this data is particularly going to solve, right? So there is a lot of data which is available, and then because it is all present in different locations, different formats, so it becomes a challenge for the companies to actually make good use of this data, right? So for making some good use of this data or for getting some insights from this data, I think companies generally have two solutions. The first one is they tend to combine this data at a single location, right? There are a couple of problems with this approach. If you have to combine the data, you will typically deploy some ETL processing pipeline, which will basically extract your data from your source databases, do some kind of transformation, and then finally load it in some HDFS or S3 or some object storage kind of location, right? This process is very tedious and time consuming. First of all, there are various challenges with this processing. Let me give you a very simple example. Let's say if you have some MySQL database and you are trying to move that data from MySQL to HDFS, right? So you will write that data to HDFS, and now if suppose your table is partitioned, or like there are two cases, right? The table can be partitioned or the table can be non-partitioned. In case if the table is partitioned, so by looking at the partition key, if there are any updates which are coming in for your data present in SDFS, by looking at the partitioning key, we can get to know which partition this particular record is going to be ingested in, or which particular partition this record is going to be updated in, right? But in that partition, we have lot of files. And now which particular file this record should be going to? That is a major challenge which was still existing, I think at least till a few years back as well. Only recently we have been able to solve this with some of the latest challenges, with some of the latest innovations in the data world. But like I was saying that this has been a problem traditionally because like you have to rewrite all the files because you don't know which file the record was going to be ingested in. And again, this leads to a duplication of your data, right? Because the same data is available in MySQL as well, and the same data is available in your SDFS location as well. Further, because you have to rewrite the data or you have to update the entire partition there, that leads to some latency before you can get the latest form of data or the most latest data, right? And the demand these days is basically for real-time data. We don't want any latency when it comes to data-related use cases. The other way in which the companies can deal with this data, which is present in different locations, is if you don't want to combine it, you have to query that data from those different data sources itself, right? So if you have to query the data from those different data sources, you have to either employ different tools, which will all be having like some kind of a SQL query language to query the data from there. But all of this SQL query languages, they actually look similar, but they behave exactly just differently to be able to give you erroneous results, right? So that is another problem when dealing with data present in different locations and in different formats. And again, there are some scalability headaches as well, right? So some systems like MySQL, they don't support horizontal scaling very well. And while they have the master slave kind of architecture where like they have some replicas which can help you in case of some emergency or some disaster, but that does not scale very well with a huge amount of data and huge amount of incoming queries. So these were some of the challenges which companies face. And while proceeding with this presentation, I'll be talking about like how these challenges are getting solved when we use single store and when we use Presto. Okay. So let us quickly talk about single store first. Single store, as many of you might be knowing, if you don't know, that's okay. Single store is a distributed SQL database which is built for speed and scale. First of all, let us try to divide this term by term, right? Single store is a distributed database. So what is getting distributed? The data present in the database itself is getting distributed in the form of partitions over different nodes, right? And basically, the best part of single store is that it is able to handle both OLTP and OLAP kind of workloads. OLTP stands for the transactional workload and OLAP stands for the analytical workload. Both of these kind of workloads, they have their own requirements in terms of the format in which the data is going to be kept, and they have their own pros and cons, right? They have their own trade-offs basically. We'll be covering all of that in some time. But the name single store, I think the name was single store because it is a single solution for your OLTP and OLAP kind of workloads. So let us quickly talk about the architecture of single store. And so basically single store, because it is distributed, so it has like different nodes as part of its cluster. There are two types of nodes basically. The first one is the aggregator node, which you can see here, and the other are the leaf nodes. Aggregator node, you can think of it as the node which is basically handling the incoming queries from the user, right? And the leaf nodes are where the database partitions are present. So what happens is when some user is submitting some query to the aggregator node in a single store cluster, The aggregator node will have the metadata about the data present on the leaf nodes, and it is going to route that query to the relevant leaf nodes, and it is going to aggregate the partial results from all the leaf nodes and give the result back to the user or the client. So as you can see here, the user is sending the SQL query to the aggregator, and the aggregator is then distributing the query to all the leaf nodes. And in high availability mode, basically the partitions on every leaf node will be having a replica in the other availability group, right? So that is what is being shown by replicates data, this arrow over here. Okay, and aggregators also are like two types. The first one is the master aggregator, and the second is the child aggregator. So the minimal configuration for a single store cluster needs to have one master aggregator and one leaf node. Okay, and it can have zero or more child aggregator nodes as well. So the master aggregator is responsible for performing all the admin kind of roles in the cluster, and also all the DDL kind of queries, data definition modification language kind of queries, will be handled by the master aggregator itself. The other type of queries, for example, the DML queries, let's say the insert updates or some select queries, can be handled by the child aggregator as well. Okay, so you can think of the leaf nodes as the workers because they are actually doing the processing and then giving the results back to the the user or the client. Okay, so in couple of slides before, like I was talking about the OLTP and OLAP kind of workloads, right? So let us try to understand that in a bit more detail. So the single store is basically it has a tiered storage kind of offering out of the box, right? Which means that single store can support row store columns as well as column store columns. Sorry, row store tables as well as column store tables. So, row store tables is a type of a table where the data is like laid out in row formats, like in the form of rows one by one. And row store tables are more suitable for the transactional workloads. So transactional workloads have their own requirements, wherein like the incoming queries are going to mostly update either a single row or a group of rows, and transactional workloads will have this requirement of getting the response in minimal amount of time, right? And also, so this row store tables, they are basically in-memory tables in single store. So there's the analogy which we are giving here, which is, let's say if you have a spreadsheet where you frequently update the individual entries, that is what you can think of as the row store table, right? Where you have all the rows and you get frequent operations which will be updating those rows one by one, versus the column store tables, which are basically laid out in columnar formats, much like Parquet files or ORC files. If you know of those file formats, they are all columnar file formats, right? So the column store tables, they are basically present on disk, and because they are mostly meant for the OLAP kind of workloads, which means that for OLAP workload, which is the analytical workload, you don't really get many frequent updates to the data. Rather, you will get more complex or more involved kind of queries, which will be run as part of the OLAP workload, right? And also, there is no requirement of giving the result in like a lesser amount of time. Basically, you need to be able to do the aggregations and all the computations on the on a big chunk of data, and you'll need to be able to give the results back. So there is an analogy which we are giving here as well, which says, let's say if you have a huge CSV file where you mostly calculate sums or averages across entire columns, right? Those kind of use cases can be thought of, which are like more suited for the column store tables, right? So such tables will be having like the way we ingest data to them is like you ingest data to them in a bulk load at a single go, and then they have very infrequent updates to the data. So basically, single store is able to support the OLTP and OLAP kind of workloads. And there is a new term HTAP which they have devised, which is like the hybrid transactional analytical processing. So they have something called as a universal storage, which is able to take care of OLTP and OLAP kind of workloads, right? So you don't need to have separate tables. Rather, with the universal storage, you can take care of both kind of workloads with the single table itself. Let us talk about the ingestion pipelines which single store supports. So single store pipelines are a technology which basically can be used for doing the ingestion of data in real time, right? And single store pipelines, they support few data sources out of the box, some of which are Kafka topic, or you have file systems like the AWS S3 or Azure or Google Cloud Storage. Along with all of this, MySQL database is also supported to be a data source for ingesting data using single store pipelines, right? So some of the cool features of single store pipelines are that they support exactly one semantics, which means even in a case of a failover, the data is guaranteed to be ingested exactly once into your single store database, right? And they maintain enough metadata for you to be able to debug if there was anything which is going wrong with the ingestion. And they can support really high throughput, which means like you will be able to ingest millions of rows within milliseconds or seconds. Another cool feature about single store pipelines is that like basically they will be watching over your data source at regular intervals to see if some new data is available or not. So that makes the job of a developer really easy when it comes to ingesting the data into your single store database. So because single store is able, it is a distributed database, so that takes care of one of the limitations which I talked about, which was scalability, right? So single store is distributed, so scalability is not a concern if you are making use of single store database. Okay, having talked about single store already, now let us quickly talk about Presto. So if I have to give you a bookish definition of Presto, so that would be Presto is a open source distributed SQL query engine, right? Let us try to break it term by term and explain each term, like try to understand each term individually. Distributed, we all know because like it is a distributed system, so the processing will be happening across different nodes, right? Presto has a master slave architecture, which I'll be talking about in some time. And what is a query engine? So to understand this term, let us think of a typical database. Like what does a typical database look like? A typical database will have like couple of layers. The first one is the storage layer and the second one is the query engine layer. So the storage layer is basically responsible for storing all the data for you, and the query engine or the SQL query layer is basically responsible for accepting the queries from the end users and then doing the processing and returning the results back to the end user. So because Presto is a SQL query engine, which means Presto is not a database, Presto is not storing any data for you. Rather, it is only querying the data in place. So wherever your data resides, Presto will be able to query it at that location itself. That actually avoids the duplication of data and all of those typical ETL workloads that I was mentioning as a challenge, right? All of that is really not needed when you're using Presto. And so Presto has a connector kind of architecture, and I'll be talking about that in some time. And Presto, from its very beginning, it has supported interactive ad hoc kind of queries, and those kind of queries are like really fast with Presto. So Presto can be thought of as SQL on anything, right? That is what I mean, if I have to describe Presto in like three words or small sentence, it will be a Presto is like SQL on anything. So let us talk about the architecture here. So if you have a look at Presto from a very, very high level, right? This is what it looks like. You have this cluster over here. which follows the master slave architecture, which means you have a coordinator which can be thought of as the master, similar to we had aggregator in single store, right? And then the worker nodes is what actually do the entire processing for you. So what happens is the client or the end user will be submitting the query, which will be accepted by the coordinator. The coordinator is responsible for planning the query, and it will be scheduling tasks onto the workers. The workers in turn will be making use of the connectors to talk to the underlying data source, and then it will be giving the results back to the client. Let us try to understand that in a bit more detail. So if you see on the right side, we have all of these different data sources which are like supported out of the box with Presto. Okay, there are many more. This is like just a small, very small subset of the data sources which are supported by Presto. So what happens is Presto has these connectors, right? And these connectors will be used by workers to read the data from the data sources. Presto as a core engine is not responsible for understanding the layout of data or the layout of metadata in the underlying data source. It is the duty of connectors to adopt Presto to the underlying data source, right? So how do the workers do that? How do the workers do that, or how do the connectors do that, right? Rather. So connectors are able to do that by implementing what we call as service provider interfaces or SPIs. So let us talk about that now. So we have this Presto coordinator, right, which is basically accepting the queries from the clients. These are all the different clients which are supported out of the box for Presto. The most common one I would say is Presto CLI, which is like a terminal-based interactive shell, which is provided out of the box. And then we have all of these BI tools which make use of the JDBC driver to talk to Presto, right? For example, Looker and Superset. So these clients are submitting the query to Presto coordinator. Coordinator is the point of contact for the end user or the client. The coordinator will typically parse and analyze the query. And how does it do that? So for parsing and analyze, what do we mean by analyzing the query? By analyzing the query, we mean that you need to ensure that the involved tables or the involved schema or the involved catalog rather, all of them are existing in the underlying data source. So that is made possible with the help of the metadata SPI. So every connector in Presto will be implementing the metadata SPI, right? And once the analysis is done, then the planning starts, which will kind of create the query plan for you. It will kind of create a abstract syntax tree for you, which will be further optimized by the optimizer, and then finally the scheduler comes into picture, right? The scheduler is responsible for getting the splits from the underlying data source, and then it will be scheduling those splits onto the Presto workers. So how does the Presto scheduler get the splits? That is made possible with the help of the data location SPI, right? Which is again like implemented with every connector. And once the tasks are scheduled onto the workers, now the coordinator is responsible for keeping track of the progress of each of those tasks. It is responsible for uh, getting the results back from the worker and then giving the results back to the client as well. And in case, while Presto supports a lot of data sources with the help of its connectors, in case there is any data source which is like not readily available with Presto, you can quickly implement that with the help of a Presto connector. And for implementing a connector, you just need to implement these SPIs. We'll have a quick look at what all connectors are available during the demo. Okay. So talking about the Presto connector, like I already told you that the connectors is what adopts Presto to the underlying data source, right? So Presto from its very beginning has enabled users to customize the different parts of query execution capabilities, right? And one of the best customization that can be done is this connector architecture, right? Like you can basically introduce new connectors to talk to different data sources. Basically, the data source you want to talk to is customizable with Presto. That is why it is called as query on anything, SQL on anything. And another point worth mentioning over here is that Presto is a federated query engine. What is a federated query engine? A federated query engine is something which is able to connect to different data sources. And Presto is a federated query engine which supports federated queries. What is a federated query? A federated query is able to scan the data from different data sources as part of the same query, right? So, for example, if we see here, we have Presto engine over here, right? And these are the different data sources, single store and S3 bucket, for example. And Presto is able to uh, scan the results from both of them. For example, if we see this query over here, select a star from single store.sales, join S3.customer data on something, blah, blah, blah. So single store and S3 are the different data sources which are getting combined in the same query with Presto. The join operation will be performed and then the query results will be rendered back to the client. Okay. Uh, right. Let us talk about some of the key features of Presto. So as I already told you that Presto is a query engine, which means that storage and compute are decoupled with Presto. Right. So basically, the storage is decoupled, and now you can scale out your compute based on your requirement, right? Presto is a highly scalable distributed query engine. And because there is like Presto can query the data in place, which means the ETL complexities are not involved when you're using Presto. Presto has the concept of optimizer, which optimizes the query plans, right? And for making use of like these optimizers are able to optimize the query plans to a great extent so as to reduce the overall execution time of your query. And interactive analytics has been the USP of Presto from the very beginning, but along with that, Presto is able to support the batch workloads as well with its recent initiative, which is like Presto on Spark. I'll not go into the details of that right now in the interest of time. And also Presto is open source, right? So anybody of you can give it a try. It is like Presto is open source because the source code is open source, and also Presto is very much open source in practice as well. So we have adopted open governance and we are a part of the Linux Foundation. Okay, so let us now talk about the combination which we have been trying to pitch in as part of this session, which is single store and Presto. The combination of both of these will be extremely useful for you when you have to create the entire pipeline for getting the insights or for building dashboards or for any kind of data related use case, right? So single store can help you with the high speed ingestion with the help of single store pipelines that we just talked about. And Presto can act as the query interface for like reading the data from different data sources and like giving the results back. So the combination of this can help you with like getting real-time ingestion from different data sources as well as real-time querying, right? Because like the analytics which is needed for building some kind of a data-driven pipelines, for most of the use cases, you need real-time data to be available there. So to have a quick look here, like for example, we have the Kafka topics. You can have different kind of data sources, right? So Kafka topics is just one illustration here. From the Kafka topics, a single store cluster can do the ingestion, and then Presto can talk to the combination of single store along with some other data sources such as PostgreSQL or S3 Data Lake to give you real-time insights into your data. Okay, so let us talk about some of the scenarios where this architecture will be extremely useful for you, right? So the first use case which I can think of is dashboards, right? So dashboards are typically used for like tracking some kind of metrics or tracking some kind of performance indicators in your production environment or in your staging environment as well. So one of the key requirements for building a dashboard is you need to have the data in real time from whichever source you want to have it, right? And in case if you were planning to have if you are planning to have the data combined from different data sources, then that becomes a problem in case if you like deploy those typical ETL processing pipelines in between. Make use of single store. Using single store, do the real-time ingestion, and then make use of Presto on top of that to do the processing in real time and get the results for you. Okay. Another good thing with Presto and SingleStore is both of them use the SQL query language whose dialect is very much ANSI SQL like. ANSI SQL is the standard SQL query syntax, I would say. And since it is the standard, which means you don't have to really worry about learning a new language in case if you are already comfortable with the standard ANSI SQL syntax. Many of the other databases like MySQL as well are making use of the standard ANSI SQL syntax. The other scenario which comes to my mind is like along with like tracking the performance indicators in production, companies are interested in knowing about the areas where more profit can be made or in knowing about the areas where further growth can be made, right? So, for solving such use cases, which involve like cross-functional analysis of data from different sources, you first of all need to understand the right data for this use case. And how do you understand the right data which should be used for this use case? Typically, what will be done is either you need to talk to someone who is senior in your team, like who has spent some n number of years of who has n number of years of experience working in the same company, who will be knowing the in and out of where the data is residing and why the data is residing in that place. Or the other way which can be done is like you make use of the tribal knowledge which is existing in your team to make use of the data correctly. But the like both of these ways can be used. But basically, if you make use of Presto over here, for example, you don't really have to like like talk to these different data sources, right? Because if you have to like query the data from different data sources, you will again have to employ maybe different tools, and again those will be having different SQL query languages, which can create confusion. Rather, make use of Presto for the same and avoid any confusions and get the data in real time. And also because like Presto and SingleStore, they both talk about the cost effective price performance. So that is why your architecture is going to be pretty scalable. So talking about some of the key benefits, I think all of these are already covered. Like we have blazing fast performance, we already know that now. Unified data access because like single store can help you with ingestion from different data sources and Presto can help you with querying the data from different data sources. The architecture becomes simplified because you don't have to really deal with different data sources now. You just need to talk to single store and Presto and your work is done. Scalability and flexibility we already know, and developer friendly. They are developer friendly as well because like we have good resources for both single store and Presto, and they are really easy to make use of. Finally, like if you are interested in trying out Presto, we have a lot of different ways to get involved with the Presto community. Either you can join the Presto Slack, which like the links to all of these you can find on the Presto website as well. In case if you are looking for contributing to the project, I would say head to the Presto GitHub repo and try to find out issues which are labeled with good first issue. Something which is labeled as good first issue is something which is like which which is labeled that way because that is good for a newcomer to get started with their Presto contribution journey, right? Otherwise, there are some meetup groups which you can join. There are working groups as well. You can join some of the working groups. Working groups is an initiative from the TSC or the Technical Steering Committee of Presto. And these working groups, they typically talk about like different components of Presto, right? For example, we have working groups for optimizer, we have working group for the overall architecture, we have working group for the security part of Presto. And you don't really need to be a contributor or a committer to be able to join one of the working groups. Anybody can join these working groups, right? And again, like one of the most obvious ways is like you follow us on LinkedIn and you get to know about all the latest talks, all the latest developments and progress which is being made within the Presto community. All right, so now let us have a quick demo. And so for having the demo, I would first of all talk about how do you install Presto. Okay. And the most easy way of installing Presto is like you get this binary from the Presto website. Let me quickly show you. So what you can do is you head to Presto documentation and go to installation, deploying Presto. And from here you can get the latest binary for the Presto server. You just need to download it and untar it, and you'll be having a folder similar to this Presto server 0.295, right? So if I quickly head into it, is the okay, is the font size visible? Not sure. Maybe it should be better now. And yeah, so once you list down the components, you will have all of this except the etc folder, right? There is something called as plugin. So in Presto, everything is a plugin. If you have to introduce a new connector, or you have to introduce a new data type, or you have to make some changes in the Presto access control layer or the Presto security, Presto authentication, everything has to be everything has to be deployed in the form of a plugin. So if I show you the content of this plugin, which is available, like supplied out of the box to you, it has all the different connectors. If you see single store is available over here. These plugins are responsible for providing the connector to the Presto server. Along with that, you have some session property managers, TTL providers, and few other things, which is like out of the scope for this talk. And I can quickly show you the etc folder which I created. If you want to follow along, maybe like you can do that as well. And if you face any challenges, please let us know. And within the etc folder, we have like these three files mainly. The config.properties file is basically the config file, which is giving you the cluster level properties, cluster level configs for your Presto cluster, right? Because it is a single node cluster, that is why coordinator is set to true. Coordinator flag means that this particular node where this flag is being set, this particular node is going to behave as the coordinator. Along with that, I have the node scheduler dot include coordinator equal to true, which means that the scheduler, which is going to schedule the tasks on the workers, that is going to include the coordinator as well. Which means that this is a single node Presto cluster, the bare minimum Presto cluster, I would say, where the coordinator is behaving as the worker as well. And then you have the HTTP port for the coordinator, and then some memory level configs which can be tweaked. And then we have a discovery server as well. Discovery server is basically an embedded discovery server which is present on the coordinator. So, using the discovery server, the coordinator is able to know which workers are a part of the cluster right now. So, as you can guess now, every worker needs to send a heartbeat to the discovery server so that the coordinator knows that this particular worker is alive and is a part of the cluster. And then this discovery URI is basically the endpoint of the coordinator itself, because discovery server is embedded within the coordinator. And let me quickly show you the JVM configs that we have introduced. So we have configs around the maximum heap size, and we generally recommend using the G1 GC, like the GC type has to be G1 GC for Presto, and then few other flags like getting heap dump on out of memory error, and like the heap region size, we are setting that as well. All of these, right? And then finally, there is a node dot properties which defines the node ID for every node, right? This property has to be present on every Presto node. And this is a random UUID, I would say right now. And along with that, there is a data directory which we are defining for this node. This data directory will be having the server logs and all the different kind of logs which are being flushed from the Presto server. So all of those will be written to this path which is provided here. And finally, coming to the catalog folder within etc. So right now I have like these three catalogs. Uh, so you can think of a catalog as something which is making use of the underlying connector. Or to put it in other words, the connector is able to adopt Presto to a particular data source with the help of a catalog. So all of these catalogs are making use of the connectors uh, like within them, right? So if I quickly show you the Hive catalog, for example, you see this property connector.name, which specifies Hive Hadoop 2, which means that this particular catalog is making use of the Hive Hadoop 2 connector. And then like we are specifying the metastore URI as well, because Hive actually needs the Hive metastore. Okay, so and now if you have to start your server, you can quickly do a bin launcher start to start it as a background service, or you can do a bin launcher run to so that the server will be starting and the logs will be available on the console itself, on the terminal itself. I'm not going to use either of these because like I'm more comfortable with starting the server on my ID itself. So I'll be starting it over here. Like we already talked about couple of ways of installing Presto server on your local, right? One is using the binary which is available uh, on the Presto documentation, and the other is using the IDE. There are a few more ways, like you can install it using Docker, using Helm charts, etc. But like all of that is out of scope right now. And while the server is starting, let me quickly go to SingleStore as well. So we are using the free edition of SingleStore for the demo purpose right now. And so it is like pretty straightforward. You can go to SingleStore website and you can like log in. Then it will prompt you to create the workspace and create the database within that. Like here is the option. If you have a look at the UI, we have this deployments over here, right? Deployments is having the workspace and the database which I have already connected. This is already created, and because this is a free edition, so it only allows you to have one database as it is displayed over here. So that is already created, right? And for loading the data, you can make use of this load data tab over here, or you can make use of the single store pipelines. Single store pipelines can be started with the SQL editor. You need to pass on the commands from here and pipeline will be started. For now, I have um, already did the loading of the data using load file option over here. So it is all straightforward. You can do that. And there's a pipeline as well, which is like uh, running for me. As you can see, I have created a table called employee within the database, and that is currently running for me. And like if you have to get the connection details, you can go to this connect tab over here, go to SQL ID, and that will show you the host, the port, and the username, password, and the database. Everything will be shown over here. So for a quick demo, let me quickly show you the single store catalog first of all. This is my catalog, right? So we have the property connector dot name equal to single store, which implies it is making use of the single store connector underlying, and the connection user password and the URL. URL is also having the database name as you can see over here, and then some flags to ensure a secured connection to the single store cluster. So this is started. Now let me go to the terminal and Uh, let me quickly set the Java home. Uh, right. And now I'm going to make use of the Presto CLI client. Just to give a heads up, the queries on my local are going to be a bit slow because I have been facing this issue since the OS is upgraded. So please don't mind, please don't like pay much attention to the speed of the queries because like the actual queries are going to be really fast. It is just the problem on my local right now. If I do a show catalogs, it is going to show me, not sure if you are able to see it or not. Right. So it is giving me the single store catalog and I can quickly do a show schemas from single store. And it is going to give me the results. It took some time, but generally it does not take that much time. As I told, this is a issue with my local setup. These queries finish within the blink of an eye, right? So information schema is a schema which is like by default available with every connector, every catalog in Presto. And this is the database which I had created on SingleStore, which I just showed you on the UI as well. I can quickly do a show tables from SingleStore dot. And while this is running, let me quickly head to the Presto docs and quickly show you the connector page. You can come to this page and go to single store connector to get a detailed documentation about what this connector supports and what it does not support. So the only table which is available right now is employees, which I've already created. And then I can do select a star from dot employee, and it is going to give me the results. So the single store connector is currently having very basic functionality, and we encourage all of you to like start contributing and start enhancing the connector so that it is at par with other connectors within Presto. So currently create table and selects are all that is supported with this connector, and like these are all the like the limitations. So for example, views are not supported, and like if you have to alter the schema, that is not supported. And with the create table statement, by default, column store table is going to be created. But like in case if you want to use a row store table, that is also possible. And here we have the results from the table already. As you can see, it is having 12 rows And yeah, so this schema was all created by default from the single store UI itself. Like I have not given any proper DDL statement. That is why the column names are being shown as column 0, 1, 2, 3, like that. All right, so that was all that I wanted to cover as part of this talk. I think we are now open for any questions anybody might have.
Thank you so much, Pratyaksh. It seems like we are at the end of the demo and we are officially open for any questions. So, folks, if there's any questions that you might have, which can be even generic in nature, you can ask anything that you may be encountering difficulty with, or even if it's related to the demo. Now is the time. If even if you don't feel comfortable asking, you'll get a recording of the session and that will have an email, that would be, I think, team@singlestore.com, and also my email would be mentioned, so you can redirect any questions to there. And Pratyaksh, if you're okay, if you have a communication email, I can add that in our follow-up email as well, so
Sure,
uh,
yeah. And
you can.
another way of like reaching out to me would be Presto Slack. So like people, if they want to reach out, please join Presto Slack, and I'm available with the with the Slack handle Pratyak Sharma, which is my name. Yeah.
Okay, that is amazing. So, I think you also shared the QR code, right? Like, I think you would like to pull that out, in on your screen so that folks can, check again
Sure.
your community. For anyone that joined late, Pratyak shared like a small snippet of. So, I think we have a question. So, you might see the community QR codes, and please feel free to check them out. And yeah, this is really relevant to the session. So, Pratyaksh, we have a question from you from Surendra. Uh,
Mhm.
they have maybe a comment or a question. Presto Optimizer utilizes AI algorithm for query performance. So, are you guys utilizing AI?
No, actually, I don't think right now we have any AI capabilities within the Presto Optimizer. So the Presto Optimizer is more about a rule-based optimizer and a cost-based optimizer. So we have certain rules which are triggered when the optimizer is running, as well as the cost-based optimizer, which makes use of the table statistics to be able to optimize the join ordering, for example, and to be able to compare the costs of different plans in terms of the CPU and memory usage, and then like come up with the most optimized plan and then do the query execution. So to your question, AI is not there right now. Yeah.
I mean, you can always utilize single store make I'm sure there has to be some way because single store has AI capabilities and then leverage the Presto connector. So I'm sure
Right.
there has to be some way, depending on your use case, if there's something that you're dealing with, feel free to reach out to us and we'll take care of your query. So, folks, if there's, do we have any other question? Because we still have 2 minutes that are left. Uh, Second. All right, Surendra says thanks. So, yeah, I think with just 2 minutes left, I think we can wrap up the questions because I don't see any other questions flowing in.
Sure.
All right. Saurabh, do you have anything else to share?
Nothing as such. Thank you, all the people who joined and learned about Single Store and Presto.
Yeah.
Yeah.
Thank you.
Thank you so much, everyone, for joining. Yeah.
Thank you.
Yeah. Thanks, Pratyaksh, for putting this together. This really means a lot. And for everyone that joined us live, it's really a pleasure hosting everyone. And we have amazing sessions that are going to be coming up. And we hope to see you all there. And Pratyaksh, this was an amazing webinar. Hope to do more in future. And yeah, thanks, everyone. Have a great rest of. Oh, we have another question from Surendra. We have 1 minute left, though. Do you want to take it
Sure.
up?
Okay.
So, uh, are you able to address this question like using the Zoom Q&A button?
Um, like I don't see. Oh, okay. Q&A.
Yeah.
Maybe.
Beside your share button.
Apple account we are using single store on Snowflake.
Oh, they're sharing a.
Okay, yeah, you're sharing info, right? Yeah, yeah. Thank
Okay.
you, thank you. Yeah, good to know.
Okay, amazing. Yeah, that's great. Uh, All right. So yeah, I think we can conclude the session. And folks, we have amazing sessions coming up. So I hope to see you all there. Thanks, Pratyaksh. Thanks, Saurabh. And for everyone that joined, have a great rest of the day. Have a great rest of the night. Take care, everyone. Bye.